Dear student, today we are going to see the Peterson solution. First, so this is a solution which is occur the problem of critical section problem. So what is critical section? Already we saw the last video. So the critical section is a kind of segment of code which run only one program at a time. So this is called as a critical section. Okay. So at the time when the program is executed in the critical section, there will be problem occurred. So we are giving the solution to that problem. So this solution is especially applicable for the critical section problem. Okay. So here first this is the definition. So actually so more than one process shared the resource, for example memory or CPU, that will be shared by many processors shared. If multiple processors shared, then the first process initially the variable has a one value. If one process access means it will modify the variable value, okay, or rewrite the values. So the information loss occurred while running the program. Okay, so then the another one is the so the location where this process occur is called critical section. So in a critical section, prevent information loss by preventing two processes from simultaneously being the same critical region or updating the same variable simultaneously. That means only one process run at the time of the run or executed in the critical section. Okay, so here the Peterson solution give the solution to the critical section problem. Okay, so here so the it's a classical solution for the critical section. Here no two process change or modify a resource value simultaneously. So the resource value cannot be changed. Okay, so in a critical section there are three sections are available. One is the entry section, the second one is a exit section, and third remainder section. Okay, then here in the any kind of process first entered into the critical section, so it first enter the entry section of the critical section. After that it executed in the critical region, then it will move to the exit section. Okay, so the remaining code left after execution, so the remaining code will be stored into the remainder code. After the execution, some of the code is remaining. So that code will be stored into the remainder section. So this is the diagram for the Peterson solution. For first process, there are three part entry. There are three section: entry section, critical section, exit section. When the process is entered into this entry section, then it will move to the critical section. In the critical section, it will be executed. Then finally, after that, in exit section, it will be exit from the exit section. The remainder section, after the execution, some of the code will be remaining, that will be stored into the remainder section. Okay, then here the Peterson solution give the following problem. Okay, so what are the following problem? So no other process must be allowed to enter it. This property is termed as a mutual exclusion. So so in the mutual exclusion, the critical section, only one process run. The remaining process are waiting for the execution. So this is called as a mutual exclusion. So then after that, the progress. One process is entered into the critical region, it will be continuously executed. Okay, so this is called as a progress. That means the process is currently running. Okay, that so yeah, in the Peterson solution, it will give the so the process has already request to enter and is waiting. So this is called as a bounding. So some process waiting for the execution, that is called as a bounding. Okay. So here in a Peterson solution, the the process are running in the user mode. So that's why we don't want get the permission from the kernel mode. Okay. So this is the another one advantage, because it will depend on the software, not depend on the hardware. So what are the advantages? Advantages means multiple processes to share and access resources. So multiple process can be shared the resources without conflict between the resources. That means there is no conflict or there is no problem occurred while execution of that process. Every process get a chance of execution. That means every process has a chance for the execution. Then the simple to implement and uses simple and powerful logic. So it's a very the execution is a very simple. Then so advantage of Peterson solution. So it run the user mode. It does not, there are two type of mode in the operating system. One is a user mode, the another one is a kernel mode. Also it run only on the user mode. That's why it need the software only. It does not depend on the hardware. So that's why so there is no use of the hardware. That's why we can easily prevent the deadlock occurring while running the program. Okay. What are the disadvantages? The disadvantage means a process may take a long time to wait for other process. So the process may take long time. It take a long time to wait for other process to come out the critical region. So it take a the time duration, waiting time is high, or it is called as a busy waiting. So it does not work the multiple CPU. That is the another one disadvantage. So the Peterson solution restricted only two processes. That means at a time only two processes executed. Example of the Peterson solution is a producer consumer problem. In a producer consumer problem, the semaphore is used for solving the problem. Okay. So this is called as a Peterson solution. Dear student, if you have any doubt about this video, please kindly give the comment below the comment section. Thank you very much for attending the class. Thank you.